Welcome back to Forge College. Today, we're diving into an explainer on defining and invoking simple routines. This sits right inside our Foundations of Solidity syntax module, which is a key part of the Introduction to Solidity and Basic Syntax course, all rolling up into our massive Solidity from Zero track. Basically, we're examining the engineer's blueprint of smart contracts to build the actual gears and levers that make them work. It's time to bring our code to life, so grab your hard hats and let's get building.
Here's our blueprint for today's explainer. 1. Giving states some action. 2. The anatomy of a routine. 3. Visibility and mutability. 4. Building a simple counter. 5. A local transaction demo. And finally, 6. Next steps and conclusion. Let's jump right in.
Section 1. Giving state some action. Waking up the machine.
So, in our previous lesson, you totally mastered control flow. You know, your if-else and statements and your loops. You've got the raw materials and basic logic tools absolutely ready to go. But right now, your smart contract machine is kind of just sitting there. It's essentially a very expensive, highly decentralized paperweight. Which leads us to the million-dollar question. How do we actually interact with our contract's state? Like, how do we build the buttons and pull the levers to make that stored state actually change? We need to figure out how to take that static, on-chain data and introduce some real dynamic behavior.
Section 2. Anatomy of a routine. The gears and levers.
To interact with state, we have to build routines. A simple routine, or as it's more commonly called in Solidity, a function, is the mechanical part of your smart contract. It acts as the direct bridge between inert data and active, useful behavior. Think of it like this. Without functions, your contract state is locked in a vault with absolutely no doors. Functions are the doors, the windows, and the delivery chutes.
Now, the function header is like the strict, no-nonsense operating manual for your machine. It spells out the name, the parameters it takes in, the return specification, its visibility, and its state mutability qualifiers. By writing this header, you're literally communicating to the blockchain exactly what this specific lever does and precisely who is allowed to pull it.
Section 3. Visibility and state mutability. Who pulls the lever and what does it cost?
Okay, let's talk about our security blueprint. Public means anyone, internally or externally, can call it. It's essentially an open house. External restricts it to outside transactions, which is super great for gas-efficient reads. Internal is strictly for contract internal calls, perfect for shared helper logic. And private? That's the ultimate VIP room. Only the defining contract itself can use it. It's basically a highly paranoid corporate security badge system for your code.
This next difference is absolutely crucial to remember, especially if you care about the health of your crypto wallet. Just looking at the machine using View or pure functions is totally free. You can window shop that data off-chain all day long. But if you want to physically move the gears to modify the state, yeah, that's going to cost you real gas to permanently alter the blockchain's record. Remember the golden rule: looking is free, touching costs gas.
Section 4. Building a simple counter. Assembling the prototype.
All right, let's take all these abstract concepts and assemble a working prototype. We'll start by defining our raw material, a private 256-bit unsigned integer that we'll just call counter. Think of that simply as a digital box that only holds positive numbers. Right underneath that, we set up a digital alarm bell, an event called counter updated. This event rings out to the off-chain world whenever our counter changes, letting user interfaces know that, hey, something just happened.
Next up is our first simple lever, the get function. Notice the keywords here, public and view. This is our free read-only window. It lets anyone check the counter's current value without paying a single dime in gas. It just promises to fetch that number for whoever is asking.
And here is the heavy machinery, the increment function. It's marked public so anyone can call it, but notice it's missing that view keyword. That means it modifies the state. It reaches right into storage, adds 1 to the counter, burns a little gas, and finally rings that counter-updated alarm bell to let the whole world know the gear has officially turned.
Section 5. The local transaction demo. Firing up the machine.
We've got our theoretical blueprints, so now let's fire up this machine locally to prove it works without, accidentally blowing anything up. By running these steps on your local hard hat node or Remix virtual machine, you can execute a totally safe test run. You deploy the contract, read the free state using get, pay some fake monopoly money gas to hit increment, check get again to see the number go up, and finally, check your logs for that alarm bell event. This sequence is exactly how you prove your code isn't just theory, it's a living, breathing machine.
Section 6. Next steps and conclusion. Wrapping up the blueprint.
As we wrap up this explainer, always keep this in mind. Your function headers are not just polite suggestions, they are the strict laws of blockchain physics. If you mislabel a visibility or mutability modifier, you could either end up burning a fortune in unnecessary gas, or worse, leaving the vault door wide open for hackers. And nobody wants that.
So what are our key takeaways? Keep these principles front and center as you design your logic. Carefully separate your free, read-only view routines from your expensive, state-modifying actions. And, as a golden rule, always run that local demo, capturing the before and after values locally to prove your logic is rock solid before you ever unleash it on a live network. For our next step, make sure you save your simple counter contract code in your local transaction screenshots. Since we're working our way through the Solidity from Zero track, in our next lesson, we'll actually be taking those exact artifacts, compiling them, and verifying these basics together.
So, the question is, are your smart contracts gears ready to start turning? I really hope this walkthrough has given you the confidence to start writing your own routines and pulling those on-chain levers. Thank you so much for joining me for this explainer here at Forge College. Be sure to visit forge.college to continue mastering the fascinating mechanics of Web3. Catch you in the next one.